Welcome to the fascinating world of abstract algebra. If you've ever wondered what lies beyond the arithmetic of numbers, you're in for a treat. Abstract algebra is a branch of mathematics that deals with algebraic structures such as groups, rings, and fields. Let's start with groups. A group is a set combined with an operation that satisfies four conditions: closure, associativity, identity, and inverses. Groups help in understanding symmetry in mathematics. For example, the set of all integers under addition is a group. Next, we have rings. A ring is a set equipped with two binary operations. Think of it like adding and multiplying numbers, but not just numbers, elements of the set. Rings generalize familiar structures, like the set of integers and polynomials. They must have properties such as associativity, distributivity, and the presence of an additive identity. Lastly, let's talk about fields, which are a special type of ring where multiplication is also commutative, and every non-zero element has a multiplicative inverse. Familiar fields include the set of rational numbers, real numbers, and complex numbers. Fields form the foundation for much of modern mathematical theory, including calculus and number theory. Abstract algebra is crucial because it provides a unifying framework for understanding different mathematical structures. It has applications in cryptography, coding theory, quantum mechanics, and more, making it an indispensable tool in both pure and applied mathematics. And there you have it, abstract algebra in 2 minutes. Now you know the basics of groups, rings, and fields, and how they tie into broader mathematical concepts. Like and subscribe for more videos like this.